Hello guys, myself. Welcome to Coach Studio. Today POTD is binary matrix having maximum number of ones. So question is, we are giving binary matrix which contains only 0 and 1. It is a square matrix and has given some information which is all rows are ordered sorted. This is important information you should keep in mind. After that, we'll make use of that. We need to find the particular number which contains maximum number of ones, and we should find that count of that particular ones. So he has given some note in case of a tie, print the smaller row number, and it is zero based indexing. He is saying, so we'll make some observation based on this example. uh, just a second. Here, you see from this test case, the number of ones in row 1 is 1, and number of ones in row 2 is 2, and number of ones in this last row is 0. So according to our row number is 0, which contains the maximum number of ones, and this should be 1 as it is 0 based indexing, and the count of number of ones is 2 in this particular example. So now our answer should be row equal to 1 and column equal to that is count should be equal to 2, as you can see here. 1 and 2, 1 and 2 will be our answer. And for the next example, as you can see, there are three number of ones in the first row, and this row has 3 and this row has 0. But if you see, there is a tie between this 0 and first row. So as you know, root in case of a tie, we should print the smaller row number. So we should take this run because we should prefer the smaller one in case of this tie. So I have preferred this row as 0 and count as 3, which is our answer, 0 and 3 for this test case. So if you see this question will come up with the idea like going through each and every on count a number of ones, and whichever is maximum will store that particular row and store that particular count, uh, maximum count. This will include iterating over each and every element, which is O of n square. We are iterating over each and every element in the matrix. So time complexity O of n square. But if you see the question carefully here, the expected is of n. So which will not work. This approach will not work here. Uh, we'll make some other observation, and we'll go with another approach. As you can see, as per my idea, I'll start with this top right element. So if I found this top right element as 1, I will just mark it the count, the number of ones as 1. And if I found next element as 0 in this row, particular row, I will go for the next row. So if I found any 0 in the previous column, then I will move to the next row. Then again I will check for the previous column whether it contains 1 or if it contains that row, then I will increase the count of 1, and I'll be updating every time that row as I, every time. This will be happening. And if you see again the next previous column element is 0, then I should move to this next row. Here there is 0, then I should exit from this. If you see here, row number 1 will be stored and count will be stored, which is our required answer, as you can see here. So this approach is working for this. Let me check for another test case. If you see this, and again I'm starting from here top right, and I'll make my count as 1, and again I will go for this previous element, and again I will increase my count. Again I'll go for this, I'll increase my count, and I'll store my row as well simultaneously. After that, I'll go to down. There is no element previously to compare, and if I again go down, there is 0, and there is no previous element to compare. I'll accept simply. So here you can see R is equal to rules and C is equal to 3. which is our required answer. So this approach is working, and we analyze the time complexity of this question even. As you can see in the worst case here we are iterating three number of times, and here also we are iterating three number of times. That is 3 plus 3, 6 times we are iterating. Suppose let's assume this is n and this is n. So in worst case also we are iterating n plus n times, and which is O of n time complexity, which is our required and expected time complexity. So we can follow this approach. So there are some edge cases like this one. If there is only a single element, that is only one by one matrix size, then this can be the edge case, or we can just make it row as zero, row containing zero, and count should be equal to one. Or we can return this one as the our base case. And one more thing I stretched is there all rows are sorted already. Why has given that point? I'll make it that understand. If this is the case, 101 and 0 0 and 1, and finally 0 1 and 0. See, as you can see, according to our approach, I'll start from here. If there is 0, I'll go to the next one. If there is 0, I'll go to the next one. It is 0, I'll exit. So here answer count will be equal to 1, but row is 0. But as you can see, there are two ones in this particular row. So which is not possible in this approach to follow. See, in of time complexity, without array being sorted row wise, we cannot solve this in of n complexity. So for this purpose, he has given all rows are already sorted. Okay, this is clear. And one more edge case is if your first row is zero. If you start finding from here, you'll go to the next row, and whenever you are counting the number of ones, you will face one kind of problem while implementing. So take this as edge case, then it will be clear to you while implementing the code. So that's what I'm implementing here. There are two edge cases, and final conclusion is whenever you find zero in the previous column, you just go to the next row. Whenever you found one, and go to the whenever you find one, right, you go just to the previous element and update your count and row as well. So this is the final approach and final conclusion. So I am initializing each and every element, and this is the base case for length one what I have shown, and this is the base case of that first row being zero, or first three rows become zero, first five rows become zero. Oh, this is the edge case of that. And here the main logic comes. If whenever I found one in the previous one, I'll just move it to the left side and increase my count and update my row number. Else I will go to the next row as I plus plus, and I'll store my answer and return it. We'll try running it. Yes, it is possible. Yes, this is our execution. Yeah, that's all. Thank you guys for watching.